In this video, we're going to look at the parts of a parabola. So I have a parabola graphed here. It's for the equation y equals x squared minus 2x minus 3. And I'm just going to point some things out. So notice that this parabola is opening up. So the parabolas that we're going to look at are either going to open up, like this one, or there are some that are going to open downwards. Okay, and they would look like such. Okay, I'm just going to put that here in a cloud. So this one opens up. Now, the bottom of this parabola is called the vertex. So this vertex happens to be at 1, -4. The vertex can either be a minimum point, which it is in this case, because it's the bottom, or it could be a maximum point, which it would be in this parabola in the cloud. So we're going to travel, well, actually, before I travel on the parabola, let's bring something else up. So if we take this parabola, notice how it's symmetric. If we cut this thing right down the middle, right through the vertex, that is our axis of symmetry. So our axis of symmetry in this case is at x equals 1. So our vertex was at 1, -4. Our axis of symmetry is at x equals 1. The axis of symmetry is always going to be written as x equals a number because it's always a vertical line. Notice that the axis of symmetry is the same as the x coordinate of the vertex. That is always going to be true. So now we will travel along our parabola, and I'm going to travel, we could travel in either direction. I'm going to travel to the right to this point at 3. That point right there is an x-intercept. It is where the graph crosses the x-axis. Notice that there is also an x-intercept on the other side of the axis of symmetry, in this case at -1. Now, x-intercepts are often referred to as roots or referred to as zeros. So we use those terms interchangeably. X-intercepts, roots, or zeros. They all mean the same thing. So I've looked at 3 different points here, the vertex and the 2 x-intercepts. Let's travel down the graph to the y-intercept. So we've looked at y-intercepts when we looked at linear equations. Okay, the y-intercept is where the graph crosses the y-axis. Now, unlike the roots, in this case, we only have one y-intercept. We will only ever have one y-intercept. Okay, we cannot have more than one y-intercept. If we had more than one y-intercept, we would not be looking at a function. That's not true of x-intercepts, of course, because x-intercepts are to the left and to the right of each other. So we've looked at 4 points, and staying with the y-intercept, notice that there is a point highlighted to the right of the axis of symmetry. You could think of this point as just being a reflection of the y-intercept. So when I have students graph parabolas, I often have them graph 5 points, the vertex, the 2 x-intercepts, the y-intercept, and the reflection of the y-intercept. That can change, however, because we can look at parabolas that have only one x-intercept. Okay, say we have a parabola that looks like this, okay, where its vertex is sitting right on the x-axis. Here we'd only have one x-intercept. We could also see parabolas that have no x-intercepts. Say you have one that's kind of opening downward this way. Okay, and here we'd have no x-intercepts. So sometimes it becomes a little bit more difficult to graph the 5 points. Okay, so though that is the anatomy of a parabola, and we're going to look how to use the anatomy of the parabola to help us graph parabolas, and we're going to use a little algebra to help us find some of these parts of a parabola in future videos.